For more updates, click on subscribe and click on bell button for latest notifications.
Hi friends, welcome to Tech ARK YouTube channel. My name is Ravi. In this video session, we are going to see that 22 real-time DevOps interview questions and answers, which interview is taken for the DevOps engineer. So that all the questions are collected and that the questions is fully answered on this video. So do not skip this video. So see the video from end to end so that you can understand how the DevOps interviews goes and what are the questions to be expected on the DevOps interview process. Let's see that. What are those questions and answers here? So the first question the interview asks is that what is your understanding about DevOps or what is DevOps? Example, so what is your understanding is about the DevOps? If you take these, DevOps is a software development approach that combines development and operations teams to foster collaboration and streamline the software delivery process. Example, this before DevOps is not introduced in the industry, the dev and the op, two different teams like the development team and the operation teams are works in their own silos, not combined together. So they works in a different silos, like operations team takes care about the operations like the server provisioning stuff and server maintenance stuff, monitoring, alerting, all this stuff. And development is completely focused on the development of the code development, application release process and production. After that, the operation team maintains the production stuff. This is like they identified the gaps in between development and the operation teams. Like development teams completely depends on the operations, that operation team should fix the hardware related issues, software related issues if there any dependencies, or network level configuration and everything. That makes the development and the operation process, like the releasing the application process, will take longer time. That way, the DevOps is not a technology. DevOps is a development approach or the process which combines dev and operations team to work together. So that's the understanding here. It aims a bridge the gap between developers and the operations personnel by promoting a culture of shared responsibility, continuous integration and delivery, and automated infrastructure management. Example, say before we used to like go, if operation teams, if development team asks the operations team saying that hey, I need so and so server with so and so configuration, the operations team goes back to the finance team and asks for the budget approval and they get the quotations and the quality check done and the hardware delivery process, hardware racking, stacking, network connectivity, operating system installation and all this stuff. So the data center maintenance and everything should take at least, if it is a faster way of the approvals and everything is completed, the server would be delivered within a 1 month of period of time, and that would be uh, ready for the development stuff. But if it is normal approval process will be lengthy process, then one server request will take at least 2 to 3 months. So they have to bargain with the vendor and they get the configuration, correct configuration requirements and everything. Then the code should be approved by the management and it should go to the all this stuff, right? So but that process will be eliminated here and dev and operations team will be combined, work together and improves the process and release the applications faster. So DevOps emphasizes the following key principles. So what are the key principles here? Collaboration and communication. So DevOps prompts effective communication and collaboration between development operations and the other stakeholders involved in the software development cycle. So that's why whatever the goals aligned or the shared knowledge would be collectively delivered or fast way to delivered. So that's why the collaboration and communication is very very important between both the teams. Continuous integration and continuous delivery. So here before this DevOps process included, so most of the tasks are manually done. So but in DevOps process, most of this stuff is continuous integration and continuous delivery. So you don't need to be a manually deploy a application or manually do a code commits and code checks. So this is an automated process. Like CI/CD is a fundamental DevOps practice that involves automating the process of integrating code changes, building, testing, and deploying applications. So it enables frequent and reliable releases. Example, a small release at a time, and multiple small releases can be released in a small frequency. So that's the main agenda of this DevOps, reducing the time between the development and the production development. So that's the main agenda of this one. So infrastructure as a code. So before DevOps, so they need to buy the infrastructure and configure it, and there might be a manual errors, human errors, so many things. But infrastructure as a code, which actually overcomes all of these challenges, where infrastructure provisioning and configuration are defined through the code. So you define the simple code and it will deploy the infrastructure how many times you deploy the same code. So that's the infrastructure as a code. And automation process, so example, so whatever the manual tasks here overcome with the automation process. Monitoring and feedback. So whatever the infrastructure you are managing, continuously do the monitoring, logging, collection, and take the feedback and improve the process. So that's a overall what understanding of the DevOps. And DevOps is not a technology. DevOps is a process and the approach to combine development and operation teams together. So that's the DevOps is understanding of what the answer. So let's see. The second question is how DevOps is different from Agile. So Agile is simply like a process, like where most of the developer uses the Agile method to deliver the applications or coding, whatever it is, right? So how it is different, DevOps and Agile. Let's see here. So the first one, Agile and DevOps are both software development approaches but focuses on different aspects of the development life cycle. So this is like similarly looks Agile also uses for the development approach and DevOps also use for the development approach, but the focus is different aspects. So what is that key area? Let's see what is the focus and the scope on the Agile and DevOps. If you see DevOps, the focus and the scope, the focus is DevOps is focuses on entire software development and delivery lifecycle. It aims to bring together development and operations team to enable the seamless integration and development, testing, development, and operation activities. So examples say that. So when a development and operations teams works together, and it actually focuses on entire software development and delivery cycle. Example, when the process of development software is started until the complete delivery to the production it focuses on. So what Agile focus and what is the scope of Agile here? So Agile primarily focuses on the software development process itself. It emphasizes interactive development, cross-functional collaboration, and delivery small increments of working software at regular intervals. So that's the Agile method. And what is the goal? So what is the goal of DevOps and what is the goal of Agile here? So DevOps aims to enhance the collaboration and efficiency between development operations teams, streamline the software delivery process, and ensure faster and more reliable development. So more reliable deployments. So like the deployment will be completely tested in an automated fashion, and it will be delivered in a reliable environment, so that to be in a faster process. So a small changes can be pushed to the production in smaller ways, so that way it actually very focused on the development life cycle. Agile is delivery valuable software to customers in short cycles, ensuring continuous feedback and adaptation based on customer needs. So Agile what actually uses, it actually delivery a valuable software to the customer in a shorter cycle. So ensuring that every time they collect the feedback and improve the process, so that way agile works. And culture and collaboration, so DevOps encourages a culture of collaboration, shared responsibility, and breaking down silos between development and operations teams. It aims to foster a collaborative mindset and prompt cross-functional communication and cooperation. So that is the key of DevOps. Development plus operations equal to DevOps. Okay, so what Agile is focused on, what is the Agile culture and collaboration here? So Agile prompts a collaborative and flexible work culture, emphasizing self-organizing teams, close customer collaboration, and adaptive planning. So that way, so here, if you have the self-organizing teams, so that means the teams are self-organized, so not a continuous collaborative with the multiple teams. Okay, so that's the one. So let's see how different it is, right? So if you take a practices and tools, what practices DevOps uses and what is the tools is DevOps used. DevOps encompasses a wide range of practices, including continuous integration, continuous delivery, deployment, infrastructure automation, configuration management, and monitoring. Popular tools like DevOps ecosystem includes Jenkins, Git, Docker, Kubernetes, Terraform, and various monitoring solutions. So this is the DevOps uses. So what Agile uses is that Agile practices include Scrum. Agile uses include the Scrum, Kanban, and extreme programming. It uses techniques like user stories, sprints, daily stand-up meetings, and retrospectives. So Agile uses tools like Jira, Trello, Azure DevOps are commonly used for project management and collaboration. So this is the practices and tools used by the DevOps and Agile. And what is the time frame where DevOps is looking and what Agile is looking here? So DevOps extends beyond development iterations and covers the entire software delivery life cycle, including development, testing, deployment, and operations. So that is the complete DevOps cycle. And Agile focuses on a shorter development iterations, typically ranging from 1 to 4 weeks. Delivery working software at the end of each iteration. So that is the Agile focus. So here the difference between the DevOps and the Agile is a major difference is that majorly the DevOps focuses on collaborating the two different teams like the development and operations as a distinct focus. They complement each other. Agile provides the framework for iterative and customer centric development, while DevOps enables the seamless integration of development and operation activities to ensure faster and more reliable and continuous delivery of software. So many organizations combine agile and DevOps practices to more efficient and collaborative software development and delivery process. So that is the major difference between DevOps and the agile. That's you can answer some of this here between agile and the DevOps. Let's see, the third question is what are the different Git commands? Example, so the Git is a powerful version control system that offers a wide range of commands for managing repositories and collaborative with other developers. So basically Git is used to commit the code, the versioning control tool, right? Whenever the developer develops the code, they commit the code, right? So what are the commands? So if you work on the DevOps, so what are the commands you use to commit the code, withdraw the code, clone the code, and push the files and all this stuff, right? So let's see some of the example commands here. One is that git init, so git initialize, which means that new git repository in a current directory. So wherever you are in current directory, so that will initiate the new repository, the git new repository, right? Git clone repository URL. So if you provide the repository URL, so which actually creates a copy of a remote repository onto the local machine. So that's the cloning of a remote repository. Git add file name. So example, if you want to add any files to the repository, adds the files or changes to the staging area, preparing them for a commit. Git commit -m and commit. So comment whatever the comment you want to add to that particular code changes, right? So records the changes made to the repository, create a new commit. Example, say that what you're doing, you're committing a new, whatever the changes you done, you're committing to the repository. So that is the git commit does. Git push origin and origin name. So it actually uploads the local commits to the repository. Whatever the uploads from local commits to the remote repository, wherever you already configured the repository and the origin name, which actually push the code to that particular origin. Git pull origin. So origin name fetches the changes from the remote repository and integrates them into a local branch. So that is the git pull will do. Git branch new feature. Example, the branch name is new feature. So what it will do is that listing and creates and deletes the branches in the repository. Example, say that git branch and new feature. So creates the new branch named new feature. So what you're doing, you're creating a new branch called new features. Next one is git checkout. Checkout actually switches to different branch or restore the files from a previous commit. This way you can switches to a new feature branch. If you say git checkout new feature, so this is the branch name which is actually switches to that new feature branch. Git merge branch name. So if you want to merge the branch, so you can use this merging. And git stash. Git stash is temporarily saves the changes that are not ready to be committed, allowing you to switch branches or pull the changes. So that's the git stash. So there are so many other commands like git log, so display the history of the commits in the repository, so and so you can do that. So these are the example commands you can provide. So there are so many other things you can also provide if you have anything. So what are the different git commands? So these are the git commands. You can example say git initiate, clone, add, commit, push, pull, branch, checkout, merge, and stash. So these are the example git commands, and git log can also be used to history the commits of the repository. So the next question is, what is cherry pick? What is cherry pick in Git? So what is cherry pick? Let's see that. So cherry picking is a Git command that allows you to select and apply specific commits from one branch to another branch. Examples, if you want to have some commits from one branch to the other branch, you can use the cherry pick to push those specific commits to the one branch to the other branch. It enables you to pick individual commits and apply them to a different branch without merging the entire branch history. This can be useful when you want to selectively incorporate changes from one branch into another branch, such as applying a bug fix or a specific feature. So Git will attempt to apply the changes from a specified commit onto a target branch. If the cherry pick is successful, the changes introduced by the commit will be added to the target branch history as a new commit. If conflicts arise during the cherry picking process, you will need to resolve them manually by editing the conflicting files and completing the cherry picking process using the git cherry pick hyphen continue is the command you can use to cherry pick that. So the question number 5, if you go to that, what is Git flow strategy? So what is Git flow strategy? Git flow is branching model and workflow for Git that provides a structured approach of managing branches and releases in a software development project. It defines a specific branch structure and sets clear guidelines for when and how branches should be created, merged, and deployed. So here is the answer that how branches should be created, merged, and deployed. So that is called as a Git flow strategy. So example, if you are creating a Git repository, so you cannot create a single Git repository and leave it, right? So you create a Git repository. Under that, you have to create multiple branches to have the segregation between the code. Example, say that one is a main branch and master branch, and one is in a development branch, and one is in a feature branch, release branch, bug fix branch, so on and so that whenever there is a feature is released, so it will be committed to the features branch, so that you can understand how many features are released. So if there is a release branch, you can see that understand how many releases we did, and you can have the hotfix branches so that you can easily track the issues which you have on that particular software development process, right? So how you do a Git flow strategy is that initialize development, release, hotfix. So these are the Git flow strategy, like initializing the repository, and development, like creating a development repository at the branch, and developers create the features branches and they commit to that code, right? And release process, when the release time comes, then the release branch will be ready and performing a final testing and bug fixing and preparing the release art fix. So if any issues comes, the critical issues comes while production code is deployed, so they do the hard fixes to fix the production issues and continue the process. So that's the Git flow strategy. Let's see question number 6. Are you working on production environment? Means, did you deploy any production code? So most of the times, most of the people may not get the opportunity to work on the production environment. If you get the environment like production deployment process or the production involvement, so what is that? Explain, like what is the code you deployed, how you follow the process to deploy the code on the production, and what is the precautions you take, and what is the timelines you follow to deliver the product on the production. So that you have to explain in detailed or shorter and faster way, so that the interviewer can understand that process. Okay, so that is the question and answer of the sixth one. So the seventh one is, are you working in any cloud environment? So DevOps means you should most of the times work with the cloud environments, but not directly in a infrastructure level might be, but you might be having a developer, then you might work on Cloud9 like the IDE platform. So what are those platforms you work on and what the tools you use? Explain to the interviewer that what are the cloud environment or the cloud tools you use. The next question is, are you using container technology? Are you using it? Then explain what is. Container technology is a lightweight, isolated, and portable approach to deploying and running applications. Containers provide a consistent and reproducible runtime environment encapsulating an application along with its dependencies and libraries. So that's the container technology provides. So it has so many advantages like isolation and portability. Example, the container, if you want to port it from one host to the another host, you just shut down the Docker container, the whatever the container you use, then copy those Docker container files on the remote machine, then switch on the Docker. So the Docker application is moved from one host to the another host. So that would be more easy to port the infrastructure And scalable and resource management is would be easier, like how many containers you want, that many containers you quickly do using the code infrastructure as a code. Reproducible research if you have anything. Continuous integration and development process that works very well with the container technology. Let's say container technology and their limited advantages what they have. Um, any security tool you are using in CI/CD pipeline, example say that if you are using the CI/CD pipeline to deploy the code or the commit the code and process using the CI/CD pipelines, in that did you integrate any security tools to do the pipeline checkings or any vulnerabilities and all? Right? There are several security tools available that can be integrated into CI/CD pipeline to enhance the security of software development and deployment processes. Right? So there are multiple deployment processes and approaches most of the organizations follows. Right? So in this example, if you use the static application security testing like SAST, there would be like Sonar Cube, check marks, 45, there are tools. Or if you use the dynamic application security testing, there would be like there are so many other tools you can use it here. So here are the some examples, like you can use AppScan, Nessus. So there are so many other tools like BlockDoc, Synapse, Nexus Lifecycle Management, all these stuffs. So you can use any of the tools, like if you have any tools you are using in your environment, you can explain that, like what are the tools you integrated with your CI/CD pipelines to maintain the security and the code scanning methodologies and all. The question number 10 is, are you using any code scanning tools? Example, the developers write this code, but how did you identify the code is proper, or the code does not have any vulnerabilities in it or any security major security issues in it? So how you can identify that? If you use it, say yes. What are the code scanning tools you can use it here? So the Sonar Cube is a popular open source code scanning tool that performs the static code analysis to detect the bugs, vulnerabilities, and code smells. So it supports a wide range of programming languages and provides the detailed reports within remediation suggestions and all this stuff. The Sonar Cube is the one, the first tool you can use it. And check marks is a commercial static tool, the static application security testing tool. You can use that as well. And 45 is also like a micro focus, is a comprehensive static application security tool solution, and that identifies security weakness and compliance issues in a code. It supports multiple languages and offers the features like vulnerability correlation, security audit trails, and integration with other security tools and all. ESL INIT is also a widely used open source tool, like for JavaScript, TypeScript, and all. Reshaper, that is also one of the tool you can use it. And Sonatype and Synops, these are all the tools can be used to integrate for the code scanning tools in the pipelines, or separate code scanning tools you can use it for checking the vulnerabilities and the code standards. How would how cloud is different from on-premises environment? So this is the question, that how the cloud is different from your on-premises environment. So there are various perspectives comes in mind that while using the cloud and the on-premises environments. One is on a scalability. Example say that if you have a one server or the one cluster infrastructure, if you want to grow it, then you have to have the scalability mechanism, how you scale it on premises infrastructure. But in comes to the scalability on the cloud, So it very easy that you can just use the scaling infrastructure on the cloud using the various methods like elasticity. Organizations dynamically scale the resource groups and all. I can put some policies, and the scaling groups, auto scaling methods can be possible to do that. But in on-premises, it's not that flexible to scale and go global in minutes. If you use the cloud, you can go global in minutes because the global infrastructure is already in place. Example, the if you take the AWS is a cloud provider, then the cloud presence, the AWS cloud presence is most of the countries, like it covers Asia regions, APAC regions, US regions, Europe regions, right? If you want to go global, you just use the AWS service and deploy the service wherever you want. But if you use the on-premises infrastructure, first of all, you have to find the place, data center, and host the server, and configure the network configurations by the public IPs and all network configurations, and then do the routing changes and all. Then that way you go global for after maybe 2 or 3 months of your searching and setting up all the infrastructure. But if you use the cloud, go global can be done in minutes. Host the service and publish the service, you go global in minutes. And cost, if you take the cost, operational cost of the infrastructure, so that would be comparatively less in the cloud because those they maintains the infrastructure pay as you go model, like whatever you use you pay for that. But on premises, if you use it or not, you have to purchase and put the infrastructure on. So that way, the cost effective will be done from the operation expenses spent upfront on the on-premises infrastructure, but in cloud, what you use, you pay as you go model. Maintenance and management. So maintenance and management for the on-premises infrastructure, you need to have the special administrators like for the maintaining your hardware, software, and all the infrastructure, everything. Disaster recovery and capital expenditure. So disaster recovery purpose, like just like if you use the cloud infrastructure, the disaster recovery would be much faster and easier to do that. Set up any cloud disaster recoveries, like example, if you have the multi-region deployments, then one region goes down, the infrastructure will switch automatically to the other region. More scalable way you can do that. Capital expenditure, so you have to spend the capital expenditure if you have the on-premises infrastructure upfront, but the cost wise it manageable on the cloud because it's a pay as you go model. So that is the main differences you can say between the cloud and the on-premises environments. The question number 12, let's see that what is that. How will you identify which resources being used in AWS? So how will you use that? If you go to the AWS console, like management console, and management console provides the web interface and manage your AWS resources. You can navigate through the different services and view services, associate each service. For example, if you check the EC2 instances, S3 buckets, RDS databases, and all the details infrastructure, you can identify that okay, what are the resources are provisioned over there. And you can also use the AWS CLI if you have little bit of AWS CLI examples, like example EC2 describe instances. It will give you all the instances which are in state, what state, running state, stopped state, all the stuff. And if you example say S3 LS, it will give you all the bucket list. If you say RDS describe the DB instances, what are the DB instances running, those will give you the details. And you can also use the SDKs if you have the programming knowledge on .NET or Python or any other SDK formats. The software development kits, you can also use that to query the infrastructure and get the details from that. And APIs, like API gateways, if you have the AWS APIs, then you can call the APIs and get those resource details as well, right? And resource group tagging, like how you can tag the resources and identify the infrastructure, like what are resource group tagging. So if you have the proper taggings, you can also identify what are the resources and what are the tags you can identify easily. And one more thing is that you can run the cost reports, and the cost explorer can give you the detailed information that what resources used, how much time, what is the billing and all, so that also can be very useful to identify that what is the cost occurred and what's the resources used and what time used, how much used, all this stuff details. So that way you can identify what are the resources being used on the AWS infrastructure or the AWS cloud. Question number 13 is, what are the good practices you follow while provisioning the resources in the cloud? So this is very important that you should follow certain guidelines or the certain best practices while provisioning the resources on the cloud. Otherwise, if it is any compromised infrastructure, the compromised host or compromised resources, it will be a huge risk for the organization. So what are the measures you have to follow? What are the best practices you follow here? So when provisioning the resources in the AWS cloud, it's important to follow best practices to ensure security, reliability, cost optimization, and operation efficiency. So these are the pillars of AWS. You have to follow those standards. Example, so first one is the security. Strong identity and access management practices, like whatever the access you give, it should be a minimal, very minimal to do the job done, not wide open the security. So the security should be, the access control should be role based and what required, and that is the minimum security they required, and that should be granted. And cost optimization, leveraging the cost management like the cost explorer, the budgets and all. Then you can use the cost explorers, and wherever it is required you cut the cost, so that way you do the cost optimization perspective. And reliability and high availability options, right? Example, if you have the single deploying region deployments, ensure that you have the multi-region deployments and high availability are the fault tolerance mechanism in place. For any services you host on the production environment, that should be have the high availability and fault tolerance, designing the applications and all, right? And look for the performance as well, like operational efficiency, what is the scalability opportunities for that as well. So these are the best practices always you should follow on the any cloud providers. What is Amazon AMI? So what is Amazon AMI? AMI means Amazon Mission Image. Amazon Mission Image is pre-configured template used to launch instances, virtual servers. Example, in Amazon Web Services, it contains the operating system, application software, and additional software or configurations required for the instance. So example, if you want to deploy some monitoring tool, anything like Prometheus you wanted to monitor, then you don't need to actually first deploy the server, install the operating system, and install the Prometheus applications and all. Like where you choose the Amazon Mission Image, where it is already pre-deployed Prometheus application and configuration, you just pick that AMI and spin up an instance. So it will just provision everything for you. So that's the AMIs are building blocks for creating and running virtual machines in the AWS cloud. That's what it is. It's like pre-configured templates. Question number 15 is, how would you add a new AMI to auto scaling? So example, you already defined the auto scaling. Then how would you define if you have the process modifications or the new AMI is developed, then how you can add into that. So example, you can modify the auto scaling group to use the new Amazon mission. Like first you have to create the Amazon mission image and update the launch configuration. Update the launch configuration. So like the configuration associated with the auto scaling group, the launch configuration defines the settings for the instances launched by the automation, like the auto scaling groups where it is there. Then you have to update that configuration file and update the auto scaling group. like which you have defined that the auto scaling groups a new launch configuration you can define on that, and verify and test like the rerun that auto scaling group and test it whether it is working fine or not. And importantly, you have to update the launch configuration and auto scaling group may be implication of your existing instances. So make sure that you are doing the correct configuration and the correct Amazon image, the machine image. Launch configuration and launch templates. What is the difference between them? So basically, what is launch configuration and launch templates? In AWS, both launch configuration and launch templates are used to define the settings for launching instances in auto scaling groups, or when manually launching instances. There are several similar purposes but have a differences in functionality and features. So what is that? Example, if you take the launch configuration, the launch configuration is an older and simpler method for defining the configuration settings for instances launched by an autoscaling group. So major differences, the key differences here is that launch templates provides more advanced features and flexibility compared to launch configuration. Launch template supports versioning, allowing you to manage and update templates more effectively. Launch templates offer additional settings and options such as detailed network configurations and fine-grained control over instance types. Launch templates are recommended for new deployments, while launch configurations are still supported while launch configurations are still supported for existing setups. So that is the major difference between the launch configuration and the launch template. Let's see. The next question is, what are ingress and egress rules in Kubernetes? What is ingress and egress rules in Kubernetes? So Kubernetes ingress and egress rules refers to a network traffic rules that controls incoming and outgoing connections to and from ports or services within the cluster. Example, within the cluster, if the communication is like outgoing, incoming between the ports and services, that is the rules like what um, traffic should go and what. So you can define the incoming and outgoing rules for that. So that is called as an ingress and egress rules. These rules are defined in network traffic is allowed or restricted between different components of the Kubernetes cluster and external resources. So example say if you take the ingress rules controls the inbound traffic into the Kubernetes cluster that define out how external clients can access the services running within the cluster. Example, if you take the egress rules are govern the outbound traffic from the ports within the Kubernetes cluster. They control the connections, maybe by the port's external resources or the destination outside the cluster. So that is the major difference between the ingress and the egress. Just like an incoming and outgoing connections will be managed by these rules. What are the ingress and egress controllers in Kubernetes? Kubernetes ingress and egress controllers are components responsible for managing and enforcing the network traffic rules related to inbound and outbound connections within a cluster. These controllers work in conjunction with the Kubernetes networking layer to enable communication between the services and external resources. Example say that if you define the rules like the ingress controllers will actually responsible for implementing the and enforcing the rules defined in the ingress resource within the Kubernetes cluster, and egress actually manages the um, outbound network traffic from the pods within a cluster. So that is the major difference. So there are something like you can define the API server rules and resources and how the communication, the communication and authentication will be done using the SSL terminations and the routing process, path-based routing, session routing, and all this stuff. So that's the controllers can enforce the rules on the network layer. How does ingress controller provide the security? So example, you say that ingress controller, but how does the ingress controller provide the security here? So ingress controller in a Kubernetes can provide a security by implementing the various mechanisms to protect and secure incoming traffic to the cluster. So ingress is basically ingress is basically a incoming traffic to the cluster. So how we can do that? Like authentication and authorization. Who should authenticate and whether the user is authenticated is authorized to log in. Right, and SSL and TLS terminations, like the communication would be encrypted while transferring the data to the application queries and anything. And web application firewalls and filterings. Examples say that ingress controllers like the have the capabilities of protecting the services against the common web-based attacks, the SQL injections, cross-site scriptings, cross-site request forgeries, and all. So that way, if you enable the firewall applications like the web firewall applications and some filterings on the ingress rules, so that will be protected. And rating limiting and traffic shaping. Examples say that like I have the 10G connection on my um, the Kubernetes cluster resources, but I'm limiting the resources. Example, the user base is less. I don't want to be enable a complete network related traffic, right? Maybe just like protecting them from the DDoS attacks, like the Daniel of service attacks, resources, exhaustion, and all, right? Limiting the traffic and shaping that would be helpful. And logging and monitoring. Example, the ingress controllers often provides the logging and monitoring capability, like capturing the detailed information about the incoming requests, response codes, and other relevant metric, so that you can easily identify that based on the logging information, whether how many connections you are getting, how many connections getting timed out, how many connections are successful, all this stuff. So that way, the ingress controllers will provide the security on the Kubernetes layer. So what is API gateway and how the gateway works in Kubernetes? So API gateway in Kubernetes is a component that acts as a central entry point, external clients to access services running within the cluster. Example, any service request you wanted to send to the Kubernetes pods and everything, you have to go through the API gateway. So that is the main communication point for all the external external facing services on the Kubernetes. It provides a single point of contact for managing and routing incoming requests, handling security, authentication, load balancing, and other related tasks. So, like example, routing and load balancing, like API gateway performs the intelligent routing information and the load balancing stuff, incoming requests, ensure the efficient distribution to the traffic. So that way, it provides the API gateway provides the major entry point. Like example, service discovery processes and the security and authentication processes. All this stuff you can be using the API gateway. That's the main entry point for the Kubernetes services. Why we need to use microservices? So why we need to use microservices in DevOps culture, right? So microservices like architecture offers several benefits that makes it a popular choice for developing complex and scalable applications. Modularity and scalability, agility, continuous delivery, technology diversity, fault isolation, and resilience. performance and maintenance. Like maintaining the microservices, it provides the modularity and scalability. Like microservices prompts a modular approach to the application development. Instead of building the monolithic application, the system is divided into the smaller and loosely coupled services. So that way, it can provide the modularity and the scalability on the infrastructure. So like loosely coupled infrastructure, it's not dependent on each service. If one service fails, the one component fails, but other components will not fail. The entire infrastructure will not fail. That's the advantage of loosely coupled and microservice environment. Agility and continuous delivery process, like example, a smaller independently deployable services and development teams can work on a different services simultaneously. So it is not dependent on one module and another module. So it provides the more agility to allow quickly response to the market changes. So that way microservices will be very useful. And one more thing is that fault isolation. So that the major part of the microservices it provides. What type of infrastructure do you provision using the Terraform? So example say that Terraform you can use it IAC, like infrastructure as a code. Using the Terraform, you can deploy any infrastructure. Example say that you can do the um, instances. Like Terraform is a versatile infrastructure provisioning tool that can provision various types of infrastructure across the different cloud providers and services, right? You can provision the um, compute instances, storage instances, and networking stuff, security stuff, most of the things, right? So that can be done using the Terraform. That's all about this DevOps interview questions. So if you have any DevOps interview questions which are unanswered in your DevOps interview, post in the comment. We are trying to make that fully answered. And next video, stay tuned. We are going to make few more DevOps interview questions and answers to help you getting your job get through and successful interview for your future and career perspective. Thanks for watching. Stay tuned. Please share and subscribe to your friends and family so that it will be helpful for us making more videos like this.